Hello, everyone. I really think that my talk was really intended to come after the panel because there was a hint on the involvement of AI and machine learning in the panel that I think was important. Without wasting time, I think I'll just dive directly into the talk. I'm here to talk about developing a smart large language model for efficient clinical note generation. This is one of the programs that have been running in the ongoing ASBCB codathon that is still running and it's about to conclude. And what inspired this project is the fact that healthcare professionals have the need to generate clinical notes for everyone who goes in there for checkup, for any challenges that may be having health-wise. So it is noted that these clinicians, each one of them on a daily basis, spend about 2 to 3 hours on documentation tasks. And this not only takes away from the time they have for patient physical care, but also leads to burnout, medical errors, and compromises patient safety. So everyone is aware of the capabilities of AI and how it makes our life easy. And therefore, we thought that we would leverage the capabilities of large language models to streamline clinical note generation. How would we realize this project? We thought to develop a large language model denoted MedNote Llama. This is a smart LLM for efficient clinical generation. And we will do this by fine-tuning a pre-trained text-to-text LLM, Llama 3B from Meta. And with this, we would be able to generate a contextually relevant and coherent medical notes. Our project, as mentioned earlier, leverages the capabilities of large language models to automate and streamline clinical note generation. Everyone knows that there is this thing of protecting patients and patient data privacy. And therefore, there was a challenge with which data to use, but luckily, PMC, PubMed Central, has this data set that they're put together. So we retrieved it and pre-processed it as shown there. And after pre-processing and getting our files, then we would go ahead and fine-tune our Llama 3B. Fine-tuning was optimized by LoRa, that's low rank adaptation, and also Ansloth. LoRa was adapted because it has added attention and MLP modules, and it also optimizes the process by reducing memory and time training. Ansloth, on the other hand, optimizes memory speed, allows for 4-bit quantization, and it also boosts performance by about 1.5 to 2 times faster with a 70% less memory need in comparison to attention to and Hugging Face. We would go on to implement our model by PyTorch, where we would upload it and implement it on Hugging Face for accessibility. Somebody would ask, why did we choose Llama 3B? Llama 3B has the access, it provides accessibility to model weights that can be locally accessed and free for anyone who would need to do research, and thus this allows for research reproducibility. This is a project that is still ongoing. and thus these are just preliminary results. Therefore, we have so far used a section of our data set to kind of fine-tune the model as of now. So we used at least 10% of our data set, our entire data set, to fine-tune the existing model right now, which is still privately available on Hugging Face. And when we evaluated how this model is working, we used the blue score. We also used ROG-L score and the BAT score as shown there in the table. The blue score is showing 0.0 because it is a single language. Blue is bilingual evaluation and study. So we are only using one language, which is English, and therefore the 0.0 blue value. And then the ROG value indicates that there is a low overlap of the longest common subsequence between the reference data and the generated data. We also have obtained is about 73% BAT score, which shows that our model is working relatively well, even though we have used a section of our data. This BAT score demonstrates that there is a semantic alignment between the predicted and reference data. And therefore, this shows that upon fine-tuning using the entire data set, this score is prone to be better, and the model would probably perform better than what we are seeing here. When we plotted our training loss and validation loss against the steps taken, we realized a difference of 0.032 as observed there. The difference between validation and training loss is 0.02 as seen here. Sorry. As I said earlier, this project is still ongoing, and thus our results just give us an insight that the model is able to generalize medical text well, and also there is space for the model to improve, and upon better computational resources and available resources, if we are availed computation support, then the model is prone to perform better and do the work that it is needed for. An alpha version is under development and improvements are ongoing. And yeah, the final result will be put on Hugging Face and will be publicly available. Thank you. Yeah, probably you can also just check me at my poster so I can explain things better.